Nearly 17 million tons of pasta rolled off production lines worldwide in 2022 alone, according to the International Pasta Organization, IPO. That's enough to bridge continents with endless strings and shapes. In the United States, consumers polish off almost 6 billion pounds of pasta annually, making it one of the nation's top food staples. What hidden machinery and precision steps turn simple dough into those familiar noodles on your plate? Pasta's story stretches back thousands of years, though its modern identity is closely tied to Italy. Early records suggest the Chinese were pulling strands of noodles as far back as 2000 BCE, while Arab traders later carried dried forms of dough across the Mediterranean. By the 13th century, pasta had taken root in Sicily and spread throughout Italy, becoming an affordable way to store wheat in a hot climate. It was during the Renaissance that pasta evolved into an everyday food, with new shapes emerging to suit local tastes. Industrialization in the 19th century brought mechanized presses, which transformed pasta from a regional specialty into a mass-produced staple. Italian immigrants carried their traditions to America, where pasta became embedded in family meals and restaurant menus alike. Today, it is not only a symbol of Italian culture, but also one of the most consumed foods worldwide, linking ancient tradition with modern industry. The journey of pasta begins with durum wheat, a grain prized for its hard texture and high protein. Unlike common bread wheat, durum has more gluten strength, which helps pasta keep its shape. Farmers harvest the golden crop in late summer, then send it to mills for processing. Inside modern mills, the wheat is cleaned with high-speed air separators. These machines remove dust, stones, and husks, leaving only dense kernels. Next, steel rollers crush the kernels into semolina, a coarse yellow flour with distinctive granules. Each grain is carefully graded, ensuring uniform size for smooth mixing later. Moisture content is checked constantly, since even a 1% difference can alter dough texture. Automated sensors take samples every few minutes, relaying data to operators on control screens. The result is a pristine supply of semolina, stored in silos until it is ready to be transformed. Semolina enters giant stainless steel hoppers, where precise amounts of purified water are added. Ratios matter. Roughly 100 kilograms of semolina requires about 30 liters of water. This balance determines whether the dough will hold firm or fall apart. Paddle mixers rotate at controlled speeds, folding the semolina into wet clumps. The goal is not smooth dough, but a gritty, sand-like consistency. This roughness ensures that later extrusion will compress particles tightly, producing pasta with proper bite. Temperature is also controlled. Warm water accelerates gluten development, while cold water slows the process. Depending on the pasta style, technicians adjust the conditions to achieve ideal elasticity. By the end of mixing, the dough resembles moist crumbs rather than bread dough. These fragments are fed forward into sealed chambers, ready for shaping. Cameras and infrared scanners check color uniformity, ensuring no dry streaks or overhydrated spots escape unnoticed. Now comes the dramatic transformation. The dough fragments are forced through heavy bronze or Teflon dies. Under immense pressure, hydraulic screws push the mixture against the patterned plates. In seconds, spaghetti, penne, or fusilli emerge with precise dimensions. Bronze dies leave a rougher surface, perfect for holding sauces. Teflon dies, by contrast, create smooth, glossy pasta often used for faster cooking. Factories choose depending on customer demand and target market. High-speed knives slice tubular pasta into uniform lengths. For elbow macaroni, rotating blades cut arcs every split second, producing thousands per minute. The constant rhythm is both mechanical and mesmerizing. Here's where interaction comes in. Did you know a single extrusion line can produce over 6,000 pounds of pasta in an hour? Imagine if a machine failure dumped all that pasta into waste bins. Wouldn't it feel like losing thousands of meals in minutes? Hit like if just the thought makes you uneasy. Fresh pasta contains nearly 30% moisture, far too unstable for storage. To preserve it, factories rely on giant drying tunnels that run for hours. Conveyor belts carry pasta through chambers where hot, dry air circulates continuously. Temperatures rise above 120 degrees Fahrenheit, but must remain carefully balanced. Too much heat can crack spaghetti strands or collapse delicate shells. Too little, and bacteria may survive. Drying takes 8 to 12 hours depending on thickness. Long pasta like spaghetti spends more time hanging vertically, while shortcuts tumble on mesh trays. Throughout, sensors monitor humidity levels, keeping fluctuations within 1% tolerance. After drying, the pasta is cooled gradually in tempering rooms. This prevents fractures caused by sudden temperature shifts. Workers test samples by snapping strands and checking interior color. Only pasta with uniform golden hue and solid structure moves forward. At this stage, it is shelf-stable and safe to ship worldwide without spoilage. The final step brings pasta from factory floor to supermarket shelf. Conveyor belts feed dried pasta into automated scales, which portion exact weights per package. Each bag of spaghetti, for example, Must contain 454 grams, no more and no less. Machines drop the pasta into plastic bags or cardboard boxes. Vacuum sealing removes air, protecting contents from moisture and pests. Clear windows often reveal the product inside, a marketing choice as much as a quality check. Printed labels provide cooking times, nutritional facts, and batch codes for traceability. Optical scanners verify accuracy, discarding any misprinted package before sealing cartons. Finished boxes move to robotic palletizers, which stack hundreds onto wooden pallets. Forklifts transfer them into refrigerated trucks or shipping containers. Within days, the pasta travels across states or even across oceans. From wheat fields to dinner plates, every step is measured, monitored, and recorded, ensuring consistency in billions of meals each year. If pasta factories stunned you with their precision, wait until you see what it takes to serve millions of pizzas every single day. Every year, Pizza Hut sells more than 300 million pizzas worldwide, according to company reports. In the United States alone, nearly 1 in 8 Americans eats pizza on any given day, says the CDC. That means ovens never sleep, cheese flows like rivers, and dough is mixed in industrial volumes few can imagine. Yet behind each delivery box is a system engineered to work at near military efficiency. How does a global chain manage to turn simple flour, cheese, and tomato into a product identical in Texas, Tokyo, or Toronto? Let's step inside the factory process behind Pizza Hut's pizza. Pizza Hut began in 1958 when two college brothers, Dan and Frank Carney, borrowed $600 from their mother to open a small pizzeria in Wichita, Kansas. Their idea was simple but powerful: bring the Italian-American favorite into a casual, family-friendly setting. Within a year, the restaurant became so popular that franchising started, spreading the brand across the Midwest. By the 1970s, Pizza Hut had grown into the largest pizza chain in the United States, with its iconic red roof restaurants becoming suburban landmarks. Pizza Hut dough can start two different ways. Some restaurants mix flour, yeast, water, and oil fresh on site. Others receive frozen dough prepared in central facilities. The frozen version requires over 20 hours of controlled thawing before use, while fresh dough takes about 4 hours to proof. Massive mixers handle hundreds of pounds per batch. The dough is then portioned into balls, each marked with a batch code for traceability. Both systems ensure identical results, giving the same fluffy crust whether in Texas or Tokyo. Consistency here is everything. Even small errors in yeast activation can spoil entire racks. That is why dough production is treated like a science, balancing fermentation speed and storage needs. Once prepared, dough balls are sent into proofing rooms. Temperature and humidity are tightly controlled, since yeast activity changes with even minor shifts. Proofing allows carbon dioxide to expand the dough, giving it the light texture customers expect. In fresh dough systems, trays move to storage coolers after proofing. Refrigeration slows fermentation, holding dough stable for hours before baking. For frozen dough, the process is reversed. Thawing replaces proofing, giving similar softness over a longer timeline. Both methods converge at the same point. Dough that is easy to handle, flexible enough for shaping, and ready for sauce and toppings. Pizza Hut's signature tomato sauce starts as concentrated paste, blended with spices in steel kettles. Dozens of gallons are cooked at once, preserving both acidity and sweetness. Once cooled, the sauce is pumped into portioning machines that guarantee a uniform layer on every crust. Cheese arrives in giant blocks of mozzarella, which are shredded by high-speed cutters into fine strands. Each shred melts predictably under heat, creating the stretch Pizza Hut promotes in its ads. Pepperoni, sausage, and vegetables are also sliced in industrial quantities. Pizza Hut is famous for its tomato base, but many people prefer creamy white sauce or spicy BBQ. Which sauce would you choose if you could only have one? Drop your favorite in the comments. Crusts are flattened, sauced, topped, and lined up on conveyors. Workers inspect for balance, but machines handle most of the speed. A misplaced topping may seem minor, yet multiplied across thousands of pies, it means serious waste. Ovens are standardized across outlets. Whether fresh or frozen dough is used, every pizza bakes in the same type of conveyor oven. Temperatures reach around 475 degrees Fahrenheit, and timers ensure exact doneness. This standardization is crucial. It means a pan pizza in Ohio tastes identical to one in Manila. Even new recipes, like the reformulated original pan pizza, are tested for years to guarantee they bake properly on these ovens. Once baked, pizzas move directly to boxing stations. Boxes are designed not only for branding, but also to control steam. Too much trapped heat softens the crust. Vents release moisture at the right pace. Each box carries a code linking back to dough batch and sauce lot, so any issue can be traced in seconds. Pizzas bound for frozen retail lines are cooled in tunnels, sealed, and stacked for transport. For restaurant orders, boxes are dispatched within minutes to delivery drivers. From dough to oven to customer, every pizza follows a schedule engineered for reliability. The process is fast, industrial, and yet designed to feel like a simple meal shared at home. Every summer in the United States, people consume more than 7 billion hot dogs, according to the National Hot Dog and Sausage Council. That equals about 818 hot dogs every second during peak season. What began as a German sausage brought by immigrants has turned into an industrial powerhouse, feeding stadium crowds, backyard cookouts, and convenience stores nationwide. But few ever see what happens inside the factories that churn out thousands of francs per minute. How does ground meat, salt, and spices transform into the perfectly uniform hot dog in every pack? Let's uncover the hidden process. Hot dogs trace their roots to Europe, where sausages had been part of food culture for centuries. German immigrants brought frankfurters and wieners to the United States in the 19th century, selling them from push carts on city streets. By the 1860s, they were a common sight in New York and Chicago, quickly gaining popularity as cheap, portable meals. The first ballpark hot dogs were served in the early 1900s, cementing their link with American sports. Mass production began in earnest after World War II, when meat processors adapted assembly line methods to keep up with demand. The hot dog became a symbol of convenience and affordability, especially during summer cookouts and national holidays like the 4th of July. The hot dog begins with cuts of beef, pork, or poultry selected for their protein and fat balance. These meats arrive at processing plants chilled, then pass through metal detectors to ensure no bone fragments remain. Large grinders reduce the cuts into coarse pieces. Each pass through the blades makes the texture finer, preparing it for blending. Fat is carefully measured, since too much will cause greasy franks, while too little makes them dry. By the end of grinding, the mixture looks like ground hamburger, but far finer. This meat base will carry spices, salt, and other ingredients that give hot dogs their signature flavor. The ground meat enters massive mixing bowls where salt, curing agents, and seasonings are added. Common flavors include garlic, paprika, and mustard seed, though exact blends vary by brand. High-speed choppers whip the mixture into a smooth paste. During this stage, ice chips are added to keep the meat cold and to improve texture. The result is a fine emulsion, almost like a thick batter. This paste is what makes hot dogs so different from traditional sausages. Instead of chunky fillings, the emulsion creates a uniform bite with no visible grain. Once the mixture reaches the right consistency, samples are tested in labs. The meat emulsion is pumped into long cellulose or collagen casings. These casings are not always eaten. Many are removed after cooking. Stuffing machines work at incredible speeds, filling hundreds of feet of casing in minutes. As the paste flows, the machine twists the casing into links at exact intervals. Each twist forms the familiar hot dog shape. Lengths of linked hot dogs drape across moving racks, looking like endless ropes of meat. Workers and sensors check for uniform size, since even small variations can affect cooking. Imagine watching machines tie off over 1,500 hot dogs every minute. Which style do you prefer? The classic beef frank or a spicy variation? Tell us your choice in the comments. This step sets the stage for cooking, where the mixture will firm into its final form. Racks of linked hot dogs enter long smokehouses or steam ovens. Inside, heat firms the meat, while smoke or steam develops flavor and color. Cooking temperatures hover around 160 to 180 degrees Fahrenheit, hot enough to kill bacteria, but low enough to preserve texture. Smokehouses use hardwood chips for flavor, while some brands rely on liquid smoke sprayed directly onto the casings. The process also gives hot dogs their reddish-brown color. Natural reactions between curing salts and heat create the distinct look recognized worldwide. Cooking takes less than an hour, but timing is critical. Undercooked franks fail safety checks, while overcooked ones split their casings. The hot dogs are then conveyed to packaging lines. Automated counters group them, often in packs of 6, 8, or 10. Plastic films seal the franks airtight, protecting them from moisture and contamination. Labels are applied with cooking dates, nutrition facts, and barcodes. Quality control cameras scan every package, discarding any that fail to seal properly. Finally, boxes of hot dogs are palletized and loaded into refrigerated trucks. From there, they move to supermarkets, stadiums, and restaurants across the country. Within days, what started as raw meat becomes one of America's most iconic foods. From delicate strands of pasta to conveyor-baked pizzas and endless rows of hot dogs, these everyday foods reveal an astonishing truth. What seems simple on your plate is the result of massive industrial systems, balancing science, machinery, and timing down to the second. Factories don't just produce food, they engineer memories, from the comfort of spaghetti dinners to family pizza nights and backyard cookouts filled with Franks. Each process shows how precision makes abundance possible, feeding millions every day with identical taste and texture no matter where you live. And yet, every detail matters. The moisture in flour, the temperature of an oven, or the twist of a casing can decide success or failure. Do you want to discover more hidden secrets behind the foods you thought you already knew? Subscribe to Captain Discovery right now so you never miss our next deep dive.